when you're solving problems involving quadratic functions, there are a couple things to keep in mind. So remember that a quadratic function has different forms, and each form is very useful. In standard form, which is right here, A represents your direction of opening, C is your y-intercept. And in factored form, well, factored form directly gives us our x-intercepts. So when your quadratic is fully factored, you can easily solve your quadratic when y is equal to 0, and it also tells us our direction of opening. So if you have a question that requires the x-intercepts, then you might want to use factored form of the quadratic. And then we also have vertex form, which is right here. Vertex form automatically gives us our vertex. So remember the x value in our vertex, that's always where our axis of symmetry is. And then our y value in the vertex is either going to be the maximum or minimum value. And you know it's a maximum or minimum value depending on that a value, because the a value tells us your direction of opening. And if you know in your problem that you're working with, you're trying to find a maximum or minimum value, then you want to work with the vertex form of the quadratic equation. And you can switch between the different forms of the equations. So you can go from standard form to vertex form by completing the square. And you can go from standard form to factored form by factoring the equation. You can go backwards too by just expanding your equations and simplifying. So these are the questions that we're going to work on, and I want you to make sure you try them all on your own. Read each question very carefully. Does the x-intercept help you in the question at all? So should you use the quadratic and factored form? Or do you need to find the vertex because you need a maximum or minimum value? Should you convert your quadratic into vertex form so you can find that maximum or minimum value? So make sure you read each question very carefully and just come up with a plan, a strategic plan on what quadratic equation, what form will help you. Our first problem says, does a quadratic function with vertex 3, -4, and y-intercept -2 also pass through the point -1.5 and 4? Explain your answer. So in this question, we're given a vertex. We're also given the y-intercept, which is just a point on that quadratic. We're not given the equation of the quadratic, but we can definitely find the equation of the quadratic, and we can find it in vertex form because we're given the vertex. So a quadratic in vertex form is just y equals a times x minus h squared plus k. And we could just fill in all this information that we know, our vertex and our y-intercept. So the y-intercept is just the point 0, -2, so we can put that into our equation. The only thing we don't know is a, so that's what we want to find so we can have the equation of our quadratic in vertex form. So when you put everything into our equation, it's just going to be 2 equals to a times 0 minus 3 squared minus 4. And here we're just going to solve this equation for a, so go ahead and do that on your own. And once you've done that, you should get that a is equal to 2 over 9. And I hope you caught my mistake earlier because the y-intercept is -2, so this y should be -2, not a +2. But a is equal to 2 over 9, so we could put that into our quadratic equation in vertex form. So it'd be y equals, instead of a, we're replacing that a with 2 over 9, and in brackets we have x minus 3 squared minus 4. So that's this quadratic in vertex form. Now we're trying to find out whether or not this point right here, -1.5 and 4, belongs to this quadratic. So what would you do? Well, in our equation, what do x and y represent? Doesn't it represent any point that belonged to this quadratic? Well, yes, it does. So then can't we just input this -1.5 and 4 in for x and y? And if this point satisfies this equation, meaning the left side will be equal to the right side, then it's definitely a part of this quadratic, and the quadratic passes through that point. So go ahead and do that. Take the value for x and y and plug it into the equation and see what happens. So on the left side of the equation, I got 4, and on the right side I got 0.5, and those are definitely not equal to each other. So then that means this point, negative 1.5 and 4, does not satisfy the quadratic equation, and the function does not pass through negative 1.5 and 4. The next question says a highway overpass has a shape that can be modeled by the equation of a parabola, and the highway is 10 meters wide. So let's draw that. So I drew a parabola opening downwards because cars go underneath the parabola, and I just made the axis of symmetry at 0. Since the highway is 10 meters wide, I knew that 5 meters to the left of 0 and 5 meters to the right of 0 would be the highway. And this just makes it 10 meters wide. This is not the only way to draw it. Some people might have drawn their parabola starting at 0 and going all the way to 10, or starting at 0 and going to negative 10, and that's totally fine. The next part of the question says the height of the overpass 2 meters from the edge of the highway is 3 meters. So 2 meters from the edge of the highway, and that could just be right here, 2 meters from the edge. So 2 meters away from 5 meters is just 3 meters. Our height is going to be 3 meters. So this point right here is just going to be 3, 3. So the height of the overpass is 3 meters when we're 2 meters away from the edge. And in the question it says there are 2 lanes of traffic that run underneath the overpass. So we got 1 lane on the left, we got 1 lane on the right. And the actual question that this problem is asking us is, can a truck that's 2.5 meters wide and 3.5 meters tall fit under the overpass? Well, in 1 lane here, the truck definitely fits if it's 2.6 meters wide. But we know at this point here, when we're 2 meters away from the edge, we have a height of 3 meters. And that's already lower than this height of 3.5. But there's still room here for the truck. From 0 to 3, 2.6 still fits. But if we're at 2.6, so if 2.6 is right here, what would the height be? Would the height be bigger than 3.5 or lower than 3.5? So that's what we're trying to find. So which quadratic equation, or which form of the quadratic equation, would actually help us solve this problem? What are we given in the equation? Well, since we know the highway is 10 meters wide, we can use that to identify our x-intercepts of the quadratic. So we're going to need factored form of a quadratic equation. So my x-intercepts are negative 5 and 5. And we already have an x and y. We know a point, and that's 3, 3. So we can input that into the equation and just solve for a. So pause the video and substitute your x-intercepts and your point into this equation, and then find a value for a. So if you put in those values and solve for a, you should have gotten that a is equal to 3 over negative 16. And we're going to use that and put it into a quadratic equation that's in factored form. So our quadratic would just be y is equal to negative 3 over 16 times x minus 5 times x plus 5. And if you drew your graph differently, you would have different x-intercepts. So remember, we're trying to find our height at this point to see if the truck is actually going to fit. We want to know if it's greater or less than 3.5. So we're just trying to find our y value. We're trying to find the height. But what's our x value? Well, our x value can just be this 2.6, the width of the truck. So input 2.6 in for x, and what y value do you get? What height do you get? So when I substituted 2.6 in for x, I got that y is equal to 3.42. So that means in this lane right here at 2.6, at the width of 2.6 meters, the height of the overpass is 3.42 meters. So does the truck fit underneath the overpass? Well, if the truck stays in this lane, which it should because it's clearly unsafe to drive into another lane, then the truck will not fit underneath the overpass. In the next question, a rectangular lot is bordered on one side by a stream and on the other 3 sides by 6 meters of fencing. So let's draw that. So we have a stream of water and then 3 sides of fencing, and we know that the fencing is a total of 600 meters. So the question asks us to find the dimensions of the lot that has the maximum area. So we're looking for the length and the width that gives us the highest area as possible. And we know that the total fencing we have is 600 meters. So let's use that information. With 600 meters of fencing, according to my diagram, I have 2 sides that are the width plus the length, 1 length, because on the other side we have the stream. So we only have 3 sides here that make up the 600 meters. And in the question, since I'm trying to find the maximum area, that should be the hint that we should be using vertex form of a quadratic equation. But how do we come up with that equation? We're maximizing the area. So we want our y value, that maximum, to be area. And we know that area is just equal to length times width. So area is the thing we're trying to maximize. It's like our y value. And we have 2 other variables here, L and W, but we only want to work with 1. So how can we get rid of one of the other variables? Well, we know that 600 is equal to 2W plus L, so we can probably rearrange this equation and isolate one of the variables. It would be easier if we just isolated for L, because it has a coefficient of 1. So if you isolate for L, we're just going to get that L is equal to 600 minus 2W. So we can substitute that back into our original equation. So we know that area is equal to 600 minus 2W times W. This is just area is equal to our length times the width. So this is a quadratic equation, but it's factored. Let's actually expand it. When you expand it, you're just going to get 600W minus 2W squared. I'm just going to rearrange it so our squared term is in the front. So it's just going to be negative 2W squared plus 600W. And since we're finding a maximum value, I think the easiest way is converting your equation into vertex form, because we know that vertex form automatically gives us our vertex and our maximum or minimum value. But there are other ways to find your maximum value, and you can still do it from factored form. So if you are comfortable with using the factored form and finding the vertex, then go ahead and do that. Otherwise, take this equation here that we have and convert it into vertex form. So pause the video and do whatever you need to find the vertex and the maximum value, and then come back and check your answer. So once you've found the vertex, that y value of the vertex is just our maximum area, and the x value of the vertex is our width. So since we have our width, we can use our width, plug it back into our equation for length, and find our length. So our length should just be equal to 600 minus 2 times our width. Our width is 150. And if we solve for that, the length is going to be 300 meters. And that just means the dimension with the maximum area is with a width of 150 meters and a length of 300 meters. So in this next question, it says, what are the 2 numbers that produce a minimum product whose difference is 9? So we're looking for 2 numbers that have a difference of 9. So we can let x represent one number and x plus 9 represent the other number. Because if we take x and add 9, then they would have a difference of 9. You may have also set this up differently if you used it on your own. You could have done x and x minus 9 as well. And in the question, these 2 numbers produce a minimum product. So we're looking for a minimum product. The product is when we're just multiplying these 2 numbers together. So if p is just the product, and I multiply x by x plus 9, we're looking for a minimum. So since we're looking for a minimum, I'm emphasizing this word, that should be the hint to use vertex form. So let's just expand this. It'll just become x squared plus 9x. Then just convert it to vertex form, and you should already know how to convert equations into vertex form. So pause the video and come back when you have your equation in vertex form. So this is what you should have gotten in vertex form. So this is our minimum product. And our x value, our first number, is just 4.5, actually negative 4.5. And it's negative because remember in vertex form of an equation, this should be x minus whatever your number is. So realistically, we would have x minus a negative 4.5. So our x value is negative 4.5, but we need to find our second number here. Our second number is represented by x plus 9. So if we just take x plus 9, substitute in 4.5 in for x, you're going to get your second number is equal to a positive 4.5. So that just means our two numbers with a difference of 9 who have a minimum product is negative 4.5 and 4.5. In our last question, the demand function for new magazine is P at x equals negative 6x plus 40. P at x just represents the selling price in thousands of dollars, and x is the number of magazines that are sold in thousands. And the cost function, C at x, is equal to 4x plus 48. C at x just represents the total cost of producing the number of magazines. So this question is asking us to calculate the maximum profit and the number of magazines sold that will give us this maximum profit. So it's really important to understand this question and to understand profit. So how do you get profit? Well, you get profit when you take your revenue, and revenue is just the money you earn from selling your product. You want to subtract your cost, so the amount of money that it costs for you to make your product. So profit is equal to revenue minus our cost. But what in the world is our revenue? We're not given our revenue in this question. Well, you should know that revenue, that's equal to the price of your item times the amount of items that you actually sell. And are we given our price? Well, we are given a price. We're given this demand function. P at x represents our selling price. So if P at x is our selling price, what is the number of items that we're selling? Well, x just represents the number of items sold. So remember, profit is equal to revenue minus cost. So our revenue is just equal to x, the number of items sold, times our price. Our price is represented by negative 6x plus 40. But what's our cost? Well, we're just given a cost function. That's C at x equals to 4x plus 48. So we need to subtract 4x plus 48. And this is just our revenue minus our cost. So let's actually just simplify this equation and get rid of all of our brackets. So we need to expand everything. And we're just going to get negative 6x squared plus 40x minus 4x minus 48. And there are some terms that we can collect here and combine. So if we combine all our like terms, we're just going to get 6x squared plus 36x minus 48. So now we just have a quadratic. And remember what the question is actually asking. We're trying to calculate the maximum profit and the number of magazines sold that will give us that maximum profit. So we need a maximum profit. So you should change this equation and convert it into vertex form. And since you know how to do that, you're going to pause this video and try that on your own. So this is what you should have gotten if you converted this equation into vertex form. Our maximum profit is this 6, but remember it's in thousands. And the number of magazines produced at that max profit is this. So this means that when there are 3,000 magazines sold, the maximum profit is $6,000.